Okay, so today let's take a look at a question on application of differentiation. So in this question, it says that an isosceles triangle ABC with AB equal to AC is being inscribed in a fixed circle of radius of 1 and center O. It's given that the angle of BOC is equal to 2 theta, and using calculus, you are supposed to show that the area of the triangle ABC is a maximum when it is equilateral. So let's draw a diagram to illustrate this situation. So we have a circle here, we have a triangle being inscribed into the circle. So we can call this point A, B, C, and the center of O. And the radius we know is equal to 1 unit. And here is given that the angle BOC is equal to 2 theta. So we know this is 2 theta. And to find the area of a triangle, we can just use the simple formula for area of triangle, which is given by half base. The base is BC, and the height is A all the way down to the middle point of BC. Maybe we can call this point M. So the height of the triangle is given by AM. Right, looking at this triangle here and this triangle here, we can make use of the secondary school knowledge on the properties of a circle, whereby it says that angle at the center is actually twice the angle at the circumference. So we know that this angle is given by theta. And this angle here is given by theta. Now, observing this small triangle here, we can actually use our trigonometry ratio, which says that sine theta is equal to opposite over hypotenuse, which is BM over 1. So we can find out that BM actually is equal to sine theta. And BC, the entire base of the triangle, is given by just twice of this, which is 2 sine theta. So now we have our base. Now let's try to find the height of this triangle. So looking at this same small triangle again, using trigonometry ratio, we can see that cosine theta is equal to OM over 1, which is OM over 1. So therefore, OM is given by cosine theta. So therefore, height of the triangle, which is given by AM. So AM will just be 1 unit. The radius of the circle is equal to 1. So it will just be 1 plus cosine theta. So therefore, area triangle ABC is given by half base. Base is given by 2 sine theta. And the height will just be given by 1 plus cosine theta. So doing a bit of simplification here, we will have sine theta 1 plus cosine theta. Multiplying in, we get sine theta plus cosine theta sine theta. Right? We can actually just keep it this way, but I think it will be slightly easier if we can do a conversion of this form because we know that actually we'll be doing a differentiation later. And if you just to keep this form, you'll be using product differentiation, which might be slightly more complicated. So my suggestion is to change this into half sine 2 theta. This is using the double angle formula. So this is double angle formula. All right, maybe we can just call area of triangle S. Right, so now we will start to do a differentiation. So ds d theta is given by cosine theta plus, so when you differentiate this, you get 2 cos 2 theta, so you get cos 2 theta. And we know that for stationary point, we will be letting ds d theta to be equal to 0. So ds over t theta equal to 0. Therefore, cosine theta plus cosine 2 theta equal to 0. So we are supposed to solve this and get the angle that gave us the stationary point. I mean stationary point because we still didn't know whether is it a maximum or minimum until we prove it later on. So for solving of this equation here, we can either use factor formula or we can just do double angle to change this into 2 cos square theta minus 1 equal to 0. Right, doing a bit of factorization, we will be able to get 2 cosine theta minus 1 and cosine theta plus 1 equal to 0. So solving for theta here, we will get cos theta equal to half or cosine theta equal to minus 1. So this one will be rejected because the angle that we will be getting here will be 180 degrees. Here, when we solve theta, we will get theta equal to pi over 3. Right, so let's erase this part to make some space. Right, so we will have theta equal to pi over 3 that give us the stationary value. But we still need to show that it's actually whether is it a minimum or maximum. So proving whether maximum or minimum, we can either make use of the first derivative test or the second derivative test. So let's go for the second derivative test. So I will just do a differentiation of this equation again. So I get d square s over d theta square will just be equal to minus sine theta minus 2 sine 2 theta. Alright, so subbing in when theta equal to pi over 3, I will get minus sine pi over 3 minus 2 sine 2 pi over 3. Alright, evaluating this result, I will be able to get minus 3 square root 3 over 2, which will give me less than 0. So therefore, it's a maximum. Right, so once we prove that it's a maximum already, then we will be subbing this value back into here to find our final maximum area. So therefore, maximum area will just be equal to sine pi over 3 plus half sine 2 pi over 3. Right, evaluating this, I will be able to get 3/4 square root 3. Alright, so we have theta equal to pi over 3, and we know that it is an isosceles triangle. So if this is a pi over 3, so therefore, these two angles will also be pi over 3, pi over 3, therefore it's an equilateral triangle. Therefore, area ABC will be equilateral triangle.